some sustainable coastal building, as well as the problem of seaside and coastal erosion. So what exactly is the problem we're facing? According to the United Nations Environmental Program, about 37% of the world's population lives within 100 kilometers of the coast, with that number being closer to 40% in the United States, even though coastal land is less than 10% of the total land in this country. Besides the populations that live near the coast full time, millions more rely on the ocean for vacations and tourism, trade, and other incomes. Certain activities, especially those that rely on the ocean year round, will be more affected by erosion than others, and the global economy can easily be altered by coastal erosion, which will especially challenge the trade and tourism industries. In this presentation, I'll give an overview of how erosion and coastal development have evolved and developed over the years, how erosion will worsen, and some up-and-coming strategies to fight this erosion. We will then explore this development both nationally and internationally and discuss how plausible certain options actually are. In this brief video, you can see the damage that can occur from cliffside erosion. Obviously, these landowners had no control over this cliffside, and sudden cliff collapses like these can be deadly and cost millions in repairs and cleanup. So, how is this problem evolving? Well, as climate change progresses, we know sea levels will continue to rise. And with sea level rise, there will be more water available to carry energy, and erosion rates and severity are expected to increase with the sea level rise. Because there will be more water available to carry energy, and will reach farther up beach sides and cliff sides, more erosion will be seen in places that previously were unable to experience this problem. Higher sea levels have been shown to cause a shoreline erosion at rates between 110 and 181 times that of undisturbed coastlines and baseline erosion. Over time, this is obviously a large amount of sediment displacement and shoreline loss. With climate change, tropical storms and other extreme weather events are expected to increase, and their impacts on coastal erosion are the most visible. As you can see in the picture, after only 4 days, this road completely collapsed. This photo was taken after a strong winter El Nino storm here in the San Francisco Bay Area. These extreme winter storms can carry more erosional energy, and as climate change continues, it will be expected that this kind of erosion will be even more difficult to prevent in the future, as well as will be more difficult to prepare for. Droughts also have their own impact on erosion. So with droughts, there is less free water in the soil to maintain plant structures, as well as or plant communities, as well as the soil structure itself. So the worst example of dry soil and drought erosion was seen in the Dust Bowl in the early 20th century. And places like California, which are already experiencing extreme droughts, are more susceptible to drought-based erosion because of the lack of this soil structure in the plant communities to keep cliff sides and other shorelines in place. With climate change and worsening droughts, this problem will only be exacerbated both on the coasts and near the edges of rivers and lakes. So the implications that this has for us is the need for new technology and for sustainable building technology. So whether this is done through coastline retention or through actually altering how structures are supported, there needs to be a push to prepare for the inevitable erosion that we will see. Current practices can remedy some of these problems that are being faced, but will also need monitoring to adjust their effectiveness. For long-term protection, it is better to develop green solutions that will not need as much monitoring and can withstand many of the different problems that will be faced, including flooding and severe weather. So some of the current problems that I mentioned are like this rock wall here on the right, and this sand movement on the left. So both of these are current practices, but again, they do need monitoring to ensure that they are still being productive. So some history of coastal building on both the east, west, and Gulf Coast, as well as internationally. Um, so historically, both the east and west coast have had to deal with similar problems, but have approached them differently. The east coast tends to build up and elevate their structures on stilts, while the west coast does not. The west coast generally generally builds seawalls or wave breaks, and we also have to contend with earthquake activity. I will delve deeper into this in the coming slides. The Gulf Coast development has the added problem of yearly tropical storms, and again, with climate change, these storms are expected to worsen and become more severe. Many East Coast and Gulf Coast buildings also have historical value to them, and retrofitting can be one way to mitigate these problems. So retrofitting includes installing breakaway walls or freeboards, which are designed to take away some of the wave energy from reaching the main part of the building, or you can elevate the structure above any predicted flooding levels. Internationally, land reclamation has been a common strategy, especially in developing countries with exploding populations near the sea. And while this strategy can be effective, it is also very damaging ecologically, as many natural ecosystems rely on sediment transport for their nutrient cycling. So on the east coast, some shorelines have barrier islands just offshore that can offer protection from waves. However, these barrier islands are subject to the same erosional processes as the mainland, and they need to be monitored and taken care of in the same ways that mainland beaches will need. Um, and barrier islands have the added problem of being able to be eroded both on the seaward facing side as well as the mainland facing side, which creates a difficult erosion control situation. East Coast houses are unique in the fact that they are sometimes designed on stilts, which raise them off the ground. And while this can limit the potential for flooding under normal conditions, it may not be enough during storm surges or particularly strong storms. The top picture can demonstrate what can happen if a building is not properly constructed. As you can see, its foundation was eroded away, and it is now leaning sideways, and the structure is no longer able to be saved and will be demolished. Seawalls can be helpful in some situations, but they can also restrict normal sediment transport. It has been shown that jetties limiting natural sand transport can have negative downstream effects. One study in Assateague Island in Maryland showed that the constructed jetties restricted the sand transport that would have normally stabilized any inland shore. On the Gulf Coast, like I said, there is added pressure from hurricanes and other tropical storms. Again, some houses are built on stilts, but they are susceptible to many of the same problems as those on the East Coast. In the Gulf Coast, there are many big cities and other economically important locations that are only a few feet above sea level, including Houston and New Orleans, as well as ecologically important features like oyster reefs. So it is important to be prepared for long-term erosion and damage. On the West Coast, we generally don't have any offshore protection, which allows most of the full energy of waves to collide with land. Especially noticeable on the West Coast are the damage to cliff sides, as you can see in the picture on the right. During storm surges, many beach fronts can even look like the picture on the left, even if there are seawalls in place. The biggest dangers on the West Coast include sudden beach collapses, which can kill people in an instant. In 2019, 3 people were killed in a cliff collapse in Southern California, and this is one of many examples of this occurring. So the same problem on the East Coast with seawalls can occur on the West Coast with groins. So groins restrict lateral movement and are built perpendicular to beaches, and if used properly can help reduce beach erosion, but again can also limit normal sediment transport and cause adverse erosion where not intended. Sea and rock walls are also a common sight, and again, these structures can be helpful for a period of time, but it is nowhere near a perfect solution. On the west coast, particularly in California, we have to worry about droughts and erosion. I'm sorry, earthquakes and droughts. Um, and as we know, earthquakes can lead to tsunamis, but they can also lead to slope failures and sudden landslides. One study found that a prehistoric earthquake during the late Holocene removed around 225,000 cubic meters of sand across a 1.7-kilometer stretch of beach along the northern California coast. Here in California, we are also waiting for um, the next large earthquake, which will cause millions of dollars of damage across the state and into the future in terms of cleanup and recovery actions. In Washington, there is a beach known as Washaway Beach, which has been losing about 100 feet um, of land per year over the past 100 years. And all three West Coast states, Oregon, California, and Washington, are facing similar problems with beach and cliff erosion and can use similar approaches, but there is not one size fits all solution approach. So, how do we move forward into the future with these problems in mind? Depending on location, there are a few different options. West Coast engineers have already started to implement jetties for coastline retention as well as wave breaks, and while this may be helpful, it can limit some offshore activities like surfing. Um, Other possible options include planting or regrowing living shorelines. So, this includes terrestrial plants that help maintain the integrity and strength of beaches or cliffs, and marine plants that help dissipate some wave energy. Already, artificial reefs are being used to help maintain marine ecosystems for recovery or to alter wave structure for surfing. However, these artificial reefs can also be useful in breaking up wave energy and producing current energy and limiting coastal sediment loss. Wetland restoration is another strategy that is beneficial for both erosion and flood protection, especially in regions that interface directly between salt and fresh water. Nationally, there has been a lot of effort put into constructing jetties and rock walls to mitigate beach erosion and sand mass transfer. Also typically constructed are seawalls, which are designed to withstand the impact of heavy waves and dampen some of the wave energy from reaching beyond beaches and continuing inland. Living shores are gaining popularity, as you can see in the top picture, as natural solutions to erosion prevention. In 2014, a paper found that no marsh or marsh sill shorelines in North Carolina were damaged after Hurricane Irene, but 76% of man made bulkheads were. While bulkheads and other less natural methods may provide some sort of wave protection, living shorelines and other natural solutions may be better able to handle more severe storms and recover more easily. Living shorelines have also been shown to store carbon, which can help with habitat protection and nutrient pollution capture. Wetlands restoration is another viable option, not only to prevent erosion, but also to prevent flooding. So, wetlands provide habitat for fish and other marine species, but have been greatly degraded over the past 200 years or so. Like coasts, however, wetlands need erosion protection. There are already similar methods for preventing wetlands erosion, including turf reinforcement and erosion control blankets, which are put over wetlands to reduce sediment transport. As wetlands get restored, they provide additional erosion control for the land behind them and make restoration efforts in these places more effective and sustainable. We can also elevate buildings either on higher ground or on more sturdy structure foundations. Um, as you can see in the bottom picture, um, this is what would happen if a building is properly constructed on elevated ground. The house was saved, but the land surrounding it was completely flooded. If done properly, elevated buildings can withstand higher waters and flooding, but this is costly both financially as well as time. Internationally, some countries are still focusing on land reclamation, and some of these countries are so focused on land reclamation that they are indirectly creating artificial islands. For example, Dubai and Malaysia. In Penang Island, Malaysia, reclaimed land increased 3% between 1960 and 2015 for a total of 9 square kilometers. The same study found that natural mangrove forests remain the same, but on the east coast of the island, there was an entire loss of mangrove forest, but this was offset by an increase on the west coast. So land reclamation can be an option to mitigate erosion and shoreline loss, but again, it is very ecologically damaging. In Latin America, there is an engineering group called Macaferry, which has designed a tube, which can be seen in the bottom picture, that is put into places on beaches to trap sediments and prevent the loss of land. This tube is made from a polypropylene material and is filled with a sand slurry to provide a barrier for sand loss and wave energy dispersion. This Macaferry tube, the Mac tube, is similar to bulkheads, but it is more flexible and therefore may be able to withstand more storms. This Mac tube can also be used for breakwaters and for groins. The European approach to coastal erosion thus far has included sand and land reclamation, and they are working to find more natural solutions. The Operandum project is attempting to find green or hybrid green-gray solutions via their open air labs in 10 different locations. This project also focuses on promoting education for natural-based solutions in Europe, Asia, and parts. Europe, Australia, and parts of Asia. In other parts of the world, the added threat of tsunamis makes development and erosion prevention even more challenging. Like we explained earlier, like we explored earlier, extreme storms have severe erosional implications, and tsunamis are no exception. And with the added impact of climate change and increasing sea levels, tsunamis are expected to become more damaging in the future. So, with all of this in mind, is it plausible? How plausible are all of these options? Economically, um, is it plausible to invest more in sea level, sorry, in shoreline retention and erosion prevention, or is it more economically um, plausible to tell people to move back from the shore? Seaside living is already expensive, with beach homes near LA averaging around $2.4 million per home, and homes in Miami averaging around $400,000 per home. So, does it make more sense to invest more money in preparing these structures for erosion or potential cliff collapse, or does it make more sense that we limit new coastal development? And ethically, should we be limiting coastal development? Should we value personal freedom more than personal protection? It has been suggested that property buyouts are a way to limit new development in flooding areas and near the coasts. And while property buyouts can result in less people being in harm's way, they can be costly to local economies. And after property buyouts, houses are usually demolished and the land is then deeded to prevent any further development. And biologically, how likely is it that we can restore natural systems? Under global warming, natural systems are already becoming damaged and having a hard time surviving. For example, in a 2-year heat wave, 90% of the kelp forests off of the California coast they died. So, is it possible to implement living shorelines and have them be sustainable for the long-term future? And what kind of policy implications does this erosion damage have? There could be policies set in place that make property owners more aware of the potential risk that they face when developing near coasts, or policies and regulations could set limits for how close someone can develop, for how close someone can actually develop near the coast. In conclusion, we need to be realistic about the threat of coastal erosion. Global warming and climate change will make coastal erosion more of a threat and danger to coastal communities around the world. Each country and state will need to determine the best way to address the problems that they are immediately facing or are going to face in the coming future. Since there are myriad options available, lawmakers and community leaders should choose the most environmentally friendly option that will best mitigate imminent danger. Ultimately, though, it is up to individuals to determine how much risk they are willing to face for their coastal properties, but they should be as educated as possible when doing so.